Hello, being a math student, or being any student for that matter, is unlike any time in history. Right now you have access to dozens, and I should say thousands and even millions of different sources, supplemental to what you're going to see in the classroom. And so even with the worst teacher in the world, or with very few in-school resources, with as little as a telephone and an internet connection, which even people in the poorest parts of the world have, you can get supplementary information just doing a simple internet search. I usually use Google, but there are plenty of other search engines out there. Whatever your favorite is, that's fine. Just simple keyword search strings like parabola formulas. You can find images, videos, I mean literally thousands and even millions per topic. You can find exercises, all sorts of different things. So long as you have the will, where there's a will, there most certainly is a way. Unfortunately, as I've mentioned in previous videos, as is one of my main beliefs nowadays, I think there is often a lack of a will in the lives of many students. And while they've convinced themselves, and I understand how this happens, but at the end of the day, I think people are convincing themselves that they can't, and then magically, therefore, they can't. And so they're doing things that harm themselves, and they're not doing things that could help themselves. So again, moving back to this parabola content, conics are a part of math where we see there's a strictly pure math part where we're dealing with numbers and variables, and then we can take those numbers and map them onto Cartesian coordinates, and that's where we really get our conics. Right? Conics are the part of pre-calculus or algebra, algebra 2 generally, where, as the name suggests, we're studying parts of a cone or a double cone split by a plane. And while it might seem abstract and sort of meaningless in the real world, you're not just walking down the street and you see one of these double cones spliced through by a plane. The study of these types of conic sections is really crucial and fundamental for simple everyday stuff, really. Whether or not we're studying these things doesn't matter, but these things do show up in every day. For example, trajectory or projectile motion is one of the most common. So here on Math is Fun, using a keyword search string of parabola formulas, I found this nifty little tool where we can adjust these slider bars and we get this equation down here. And simple quadratic equation here where we've got a basic polynomial with ax squared plus bx plus c. And then using that slider we can see how the graph changes as we move that slider up and down. We can see that the conic flips directions from a positive to a negative, and so the ball goes up and down, or the down and up, like I suppose they have a balloon here because it's going up and up. And then we can move the vertex above the ground. We can move it from side to side, right, and do any number of different things by sliding those numbers within this range here of -3 to 3, -5 to 5, -10 to 10. You can see the graph changes quite a lot. And so there's a little bit of vocabulary involved in every part of math and every subject. Of course, we have to communicate about the thing with a language other than mathematics, other than numbers. And now the computer is just communicating in zeros and ones, but those zeros and ones are then, that's the encoding. That's the encoded data, and it's decoded or translated into some sort of linguistic pattern, i.e. words. So we've got words like directrix and parabola and focus. And basically a parabola is a curve where any point is at an equal distance from A, the focus, and B, the directrix. And then we can find there's all sorts of other things here too. Other words we can study more in detail. But we can find that formula by looking at some other websites and other sources here. And you're going to find it in a couple of different formats. You can find it in the standard form, which we generally see the parabola, like y equals x squared, ax squared plus bx plus c. And so we've got a vertex, and that vertex is the bottommost or leftmost or rightmost point. We have y equals x squared. Generally, that's what we're dealing with. The y plane, or the y-axis, is the dependent variable, and then the x-axis is the independent variable. And so our parabola is generally the ones we're working with in math class, and even indeed in real life. These are studied with this type of graph here, where we've got a U-shape opening up, or like a upside-down U-shape opening downward. And that vertex is the bottommost or topmost point, depending on if it's opening upward or downward. Right? And if it were opening right or left, then we're going to have like y squared equals x, where in this case it looks like x is actually the dependent variable and y squared, or y, is the independent variable. Or we could take the square root and say this is actually y equals the square root of x, where the square root of plus or minus the square root of x. And so, again, moving back to some more of the numbers, different people have different learning styles. It's important to understand that some people are great at just memorizing these basic formats, and then they can go and work with the numbers, and they can know that, oh yeah, y squared equals 4x, and they don't really even need to look at the graphs all the time, or they can just kind of deduce what's going on by learning the rules, and then, again, through deductive reasoning, applying the rules. Other people, well, they have to learn inductively. They have to actually do. They learn by doing, rather than learning by memorizing and then applying rules that they memorize. They had to sort of structure the rules, put them together more intuitively, or in a different way, right? And that would be inductive learning, where they're learning through doing. So this is a great program here I've used many times, Geogebra. I've got number 5. It's available on phone, Android and iPhone. It's available on Mac and PC, and I think there's even a web version. They're up to number 6 right now. And so this has got basically all of our general graphical and some scientific calculator functions in it. Whereas when I was younger, we had the TI Texas Instruments calculators, and they ran about $100 a pop, or even more expensive, between $70 and $150, depending on the model. Now for free, or for as little as $5, we can get a real fancy version of something like Geogebra or Wolfram Alpha, or any number of different graphing and other scientific calculator applications. Whereas just about everybody's got a smartphone anymore, or nearly everybody does. And then public libraries or your friend's house or whatever, you can find access to the internet. So we've all basically got access to all this different stuff right now. And if we learn English, or if our school's instruction is in English, then we're kind of at an advantage, because there's so much English content on the internet. It's like something 50%, 80%, a large percent of the internet is in the English language, right? And so I like to say there's kind of no excuse. The only excuse is that, well, I was playing video games, or I didn't want to, or I was watching television, or I was playing on social media. And that's more of a reason than a valid excuse for not learning. But anyway, as we said in that previous web page here, a parabola is a curve where any point on it is an equal distance from the focus and a fixed line, the directrix. And so here's our directrix, and what I did on Geogebra is just wrote directrix and then C, which is the name of our conic. In our conic here we have a y squared equals x. I could have just as easily done the x squared equals y, but I don't have that one highlighted right now. So our directrix C is equal to negative 0.25. And we can see here that our directrix equation for the format y squared equals 4ax, equation of the directrix x equals negative a. And so negative a is supposed to be negative 0.25. And that fits because 4 times 0.25 is 1. And if we have y squared equals x, which we have here for c, then negative a is negative 0.25. Makes sense, right? So again, y squared equals 4ax. So y squared equals 4 times 0.25x, and then the directrix is x equals negative a, or x equals negative 0.25. Easy enough. And then for this point here, b, I just typed in focus of c. So that focus is supposed to be a comma 0. A comma 0 for our first one there. And then we have, yep, sure enough, 0.250. And that makes perfect sense because the vertex is going to be equidistant between the focus and the directrix. And if our directrix is negative 0.25 and our focus is 0.25, then we can find our vertex, of course, is going to be right there at 0, 0 at the origin. And it's at the origin because we don't have any other terms. We've got y squared equals x. We don't have y squared plus 2y plus 3 or something like that. We could change where this thing is by moving it up and down or to the right or to the left or whatever, and you can see that we're adding parts to that polynomial over here, right? The equation is changing as we move the conic around, but when it sits at the origin, then our vertex right there is 0, 0. Our directrix is x equals negative 0.25, and our focus is 0.250. So every point on this line, or on this parabola here, is equidistant from the focus and from the directrix. And so that means that if I took and I measured the distance from A to B and from A to line G, then I would get the same distance. And sure enough, there it is. And as I trace, then we can see that both of those change at exactly the same rate. So in fact, it proves true that the parabola is a set of points which are equidistant from a line called the directrix, and that's a line drawn perpendicular from that point down to that line, and then a line segment drawn directly between the focus and that point. Sure enough, it proves true. And so there are lots and lots of different ways that we could draw different parabolas and do basically the same experiments. And if you have Geogebra at home, you can kind of experiment around with this. You can change the skewness, or you can shrink, you could narrow the parabola, you can widen the parabola, you can turn it upside down, you can move it side to side, up and down. And you're going to see that the parabola equation changes along with those changes in the graph, right? And so again, there's a numerical or a purely mathematical or numbers and letters based way of writing these things, right? And you can find plenty of those formulas, and you're probably expected to memorize several of those formulas. Although again, different people have different skills, different strengths, and some people are stronger in memorizing the pure math part, and then some people are stronger in working with the data in a graphical form or intuiting things by using the technology or applying these things in the real world. And so long as a student gains a fundamental functional understanding of what these things are and how they apply in the real world, well, with technology these days, I personally don't care if a student is able to work all this stuff out in his or her head, or if they have all of these different things memorized, because they are all available at a push of a button. Now, of course, then on standardized testing, we're seeing that, well, you know, people who go through this very specific, rigid type of instruction and memorize these very specific things in preparation for those standardized tests do better on standardized tests, and then that sets them off on a path towards some sort of relative victory in comparison to those who don't learn these very narrow ways of thinking about the mathematics. But in the real world, well, I think it's absurd that one would suggest that engineers and everybody has just got all of these different facts and figures and equations and formulas just on speed dial, so to speak, in the brain. Now they have a more intuitive and functional understanding of what these things are and how they apply, especially. But of course, if we're not using it, we might lose it. So that's why we have all of this static and dynamic and at least long-term retained memories, culturally retained memories on things like Cliff's Notes and what is this here? BYJUs and Math is Fun and so on and so forth. The hundreds and thousands and even millions of different places you can find extra stuff online and in all of your textbooks and things like that. And so I recommend trying to work with these things. Grab Geogebra, take a few minutes, type in some basic equations, fiddle with the numbers, play around with these things, see how the graphs change. Right? See how you can shrink it and widen it and turn it upside down and move it right to left and side to side. And see if you can't start to intuit how these different parts of the parabola are moving and changing with the different changes in the polynomial form there. Okay, thank you.